I'm here with Yev Bronstein, and Yev today is going to talk to us about using DevOps with Azure Spring Cloud. Take it away, Yev.
Thank you, Brian. My name is Yev Bronstein, and we're going to talk about how you might follow a DevOps process with Azure Spring Cloud. Now, DevOps, first and foremost, is about people and process, not about technology. So instead of specifying a particular approach, I want to show you the tools and techniques available with Azure Spring Cloud so that you can pick the ones that work best for your organization. Now, in this talk, we're going to be using Azure pipelines. However, all of the technologies and approaches we're going to talk about are applicable to any other CI/CD tool you might use, such as Jenkins or GitHub Actions. So here's our agenda for today. We're going to talk about making pipelines to provision your application environment, for building your application, for deploying your application to Azure Spring Cloud, and to top it off, we'll cover some best practices. We're going to divide the process into three distinct pipelines: one to provision your environment, one to build your application, and one to deploy your application. And the reason for making these pipelines separate and distinct is that you might want to orchestrate them differently depending on your scenario. For example, in production, you might want to provision once, but then build and deploy regularly, provided that you have rigorous automated tests. In a nightly build environment, on the other hand, you might want to do the build first and then only provision an environment if the build passes. So we're going to keep these three pipelines separate and distinct, knowing that they do work together. So let's start with provisioning your application environment. There are two common approaches we see customers use. One is Terraform, and the other is Azure Resource Manager templates, or ARM templates. So let's talk about Terraform first. The advantage of Terraform is that it has broad industry support, and you can reuse your Terraform skills across different products and across different clouds. I have a sample Terraform script here to provision an Azure Spring Cloud instance and an app in Azure Spring Cloud. Once we have our Terraform script, let's talk about how to put it into a pipeline. With Azure Pipelines, you're going to need to get the Azure Pipelines Terraform task. If you access the link on the slide here or accompanying the video, you will go to this page where you can click the Get It Free button to add the Azure Pipelines task for Terraform into your organization. And then once you have this task, you can navigate to your pipelines and just create a new Azure Pipelines with two Terraform tasks. You don't actually have to remember how to do all of this from scratch. You can just search for Terraform in the assistant on the side, and you will get a user interface for creating the tasks you see here. In this pipeline, I have two tasks, one to run the init command and one to run the apply command. Just as a reminder, if your Terraform files are not in the root directory of your repository, you will want to provide this working directory parameter to specify where they are. And once you have this, you can click Run, and that's going to provision the environment automatically. And again, you might do this nightly for nightly builds or only once for production builds. You can use the same pipeline. So let's talk about how you might use Azure Resource Manager or ARM templates instead. Now, ARM templates work very similar to Terraform in that you're specifying what you want in your deployment, and then Azure Resource Manager will create that environment for you or update that environment for you. The advantage of ARM templates is that you're not starting from scratch. If you have an existing environment, maybe one that you've created in Azure Portal, you can just navigate to that environment. So let's say I have my resource group here containing my Azure Spring Cloud instance and a database. And I can go to Export Template, and this will generate an ARM template that I can use. I can use it verbatim or perhaps parameterize it to suit my needs. And those are the two most common approaches for provisioning your environments reproducibly and consistently with Azure DevOps and Azure Spring Cloud. So now let's talk about how you would build your Azure Spring Cloud application. Build process typically consists of 3 steps that are independent of the environment that you're provisioning or deploying to. First, you would run the Maven or Gradle build. You would copy all the jars you've created to a staging directory, and then you publish that directory as an artifact of the build pipeline so that other pipelines could consume it. And to get started with this is very easy. If you have Azure Pipelines open, you can click on this new pipeline button, and you will get a template for getting started. So I will choose the location of my code. I'll use this fork here. And from the templates, I can scroll down to Gradle or Maven and choose the one that's appropriate for the project. Now, right off the bat, this gives me a Maven task to build the application. So I just need to add 2 more. I can use the assistant here to add a copy files task to copy all the jar files to a staging directory. And I can then add a publish task, publish build artifacts right here, to then make these artifacts available to the subsequent deploy pipeline. And I have a completed pipeline here. There's the copy task and the publish task. And the links to all of these will be available at the end of the slide deck if you download it. So that's the build pipeline. This is independent of any particular environment. So let's focus now on actually deploying the application that we've built to Azure Spring Cloud. Typically, we see 2 patterns with deployment environments that customers use. These are not mutually exclusive. One is that customers will have different environments for different stages of deployment. So there might be a test or dev test environment that gets regular deployments, a QA environment or a staging environment that's more production-like, and ultimately production itself. You can certainly do this with Azure Spring Cloud, but there's another pattern as well. Azure Spring Cloud offers blue-green deployments as a feature of the product, which means that you can have one deployment of your application running and receiving production traffic while uploading another deployment that's running in the same environment but not receiving production traffic, so that you can independently test your changes on a private endpoint and validate that you can have reasonable confidence in those changes before any production traffic sees those changes. Once you've validated your new deployment, you can set that deployment as active so that it receives all of the production traffic. And you can combine these 2 patterns. So for instance, maybe once you deploy to a QA environment, you'll want to do some manual testing by your QA team, but at the same time, on each deployment, you might want to do some automated testing before making that deployment active. So these 2 patterns can combine very powerfully with Azure Spring Cloud. To actually accomplish these deployments, all it takes is a couple of commands with Azure CLI. When we're working with a single deployment, the command you need is the AZ Spring Cloud app deploy command. This will create a new deployment. This will upload the application to Azure Spring Cloud. And although we're not using blue-green deployments in this case, Azure Spring Cloud will still make sure that your app is up and running before taking down the old instance. If you do want to use blue-green deployments so that you can do additional automated testing before routing traffic to the new deployment, you can use the AZ Spring Cloud app deployment create command. This will create a new deployment that will only be available on a private endpoint. Once you've established your confidence in the changes you're deploying, you can use the AZ Spring Cloud app set deployment command. That will make the new deployment active, and it will receive production traffic. So let's look at how we might orchestrate this with Azure Pipelines. So here I have a release pipeline, and you would find this by going to Azure Pipelines and clicking on Releases. First, I would define the artifacts component. This is what we are deploying. And you can see I've specified the build pipeline as the source of my artifacts. so that when this runs, the artifacts published by the build pipeline will be downloaded. Note, I can enable continuous deployment so that all the new changes are automatically deployed, or perhaps only new changes on the master branch. Next, I have a stage task for each of the microservices or applications I'm deploying. The stage task will create a new deployment that's available on a private endpoint. All of these tasks have a single task group that's parameterized for each application. But under the covers, all these task groups do is run the same AZ Spring Cloud app deployment create command that we just talked about. Once each of the apps is deployed, I can have some additional validation before routing production traffic to the app. First, I might get a manager's approval. This allows the next stage to be blocked until one of the select approvers approves the deployment. To ensure some additional testing or requirements are met, I can create a gate. For example, I might block the rollover to production until all the high priority work items have been resolved. I might invoke a REST API to hit an additional health check endpoint, or I might invoke an Azure function to perform an integration test. Once all the constraints have been met, we have another task group which under the covers runs the AZ Spring Cloud app set deployment command. All of this is just orchestration around Azure CLI and Azure Spring Cloud that allows me to follow a flexible, highly automated, and reliable DevOps process. So let's talk about some best practices for using Azure DevOps and Azure Spring Cloud. First, we talked about having 3 distinct decoupled pipelines. This is important. When you decouple pipelines from each other, you allow yourself and your developers to troubleshoot and rerun any one pipeline without influencing all the others. For example, you might want to have several attempts at redeploying a build without having to rebuild the application. And you certainly shouldn't need to tear down and re-provision environments or update your environments just to rerun the build pipeline. And similarly, the pipeline definitions should be decoupled from the environments onto which you're deploying so that one pipeline can be reused across multiple environments. This will help keep all your environments, dev, test, QA, and production, consistent with each other. You'll want to minimize duplication among your pipelines. You can use variables, parameters, task groups, and templates to use the same code, the same flow, the same logic across all your pipelines. This will eliminate customization you have to do from project to project or from environment to environment. And keep in mind, if you have YAML pipelines, you can create multiple pipelines with the same YAML file, where only some variable values can change. This will allow you, for example, to create a provisioning pipeline for your test environment, your QA environment, and your production environment, all with the same YAML. But each pipeline can have different permissions so that only the users who are allowed to touch that particular environment can run that pipeline. Next, let's talk about protecting secrets. Unfortunately, we see many customers where secrets, credentials, or passwords are available in plain text. Familiarize yourself with the mechanisms that Azure DevOps and Azure provide for keeping your secrets safe. In Azure pipelines, you can have secret variables that are injected into the environment of your tasks. You can have secure files that are downloaded as files to be available to your tasks. And for any secrets that need to be available both during deployment time and at runtime, Azure Key Vault is often the right answer. All the links on the slide will take you to the resources you need to get started with all these tools. And lastly, in Azure pipelines, you can cache the Maven repository so that you're not downloading the same artifacts from one build to another. This will not only speed up your builds, but help you have more reliable and reproducible builds, so that if Maven Central or another public repository becomes unavailable, your build can still complete successfully. All the sample materials you've seen in this video are available on GitHub. If you download the slide deck, this slide will have all the links. Lastly, we have many additional resources for you to get started using Azure Spring Cloud, and I hope you'll check those out. Thank you very much.
Thanks very much, Yev. That was wonderful. I really, really like how easy it is to use Azure pipelines to make the deployments directly to Azure Spring Cloud using the CLI behind the scenes. That's a great way to do it. And it's good to know that the CLI is being used behind the scenes as well. So thanks a lot for that. That was great.
Thank you, Brian.